Solving an equation for a variable. Like in any game, when solving an equation for a variable, there are a few rules we must follow. There are actually 3 rules which will allow you to solve any one-step equation. So here are the 3 rules, and instead of looking at them all at once, let's really examine them one at a time and break down what they mean and how they are helpful and what they mean when solving a one-step equation. So the first rule is to undo a mathematical operation, you must do the opposite. So we've learned earlier that for every mathematics operation, there is an inverse operation which undoes it. Think about addition has subtraction, multiplication has division. There's those opposite operations. So when you do both operations, you get back where you started. Think about if I add 5 to something and then subtract 5 to something, I'm back to that something. If I multiply by 2 something and then divide by 2 the something, I'm back to the something. So when the variable for which we are solving is connected to something else by a mathematical operation, we can eliminate that connection by using the inverse of that operation. We want to get the something by itself. Again, we're taking advantage of these inverse operations. The second rule is you can do anything you want except divide by 0 to one side of an equation as long as you do the same to the other side. So what that means is if the 2 expressions on the opposite sides of the equal sign are equal to begin with, they will continue to be equal if you do the same mathematical operation to both of them. This allows you to use those inverse operations that we were just talking about, so important for rule number 1. It allows us to use that on one side to undo an operation as long as we also do it on the other side. So the other side of the equation, you might not think it needs it, but if it needs it to undo and be an inverse operation to get a variable by itself, we can do it to that other side and keep the equality. The only thing we have to remember is that we can just never divide by 0 or by something which turns out to be 0, since the result of that is always undefined. So we have to make sure that that never happens when we're using this second rule. When we're doing any of these inverse operations, we just never want to divide by 0 or something that turns out to be 0. The third rule is that you can always switch the left and right sides of an equation. Once an equation has been solved for a variable, it'll be a lot easier to use if that variable is moved to the left side. Mathematically, this has no effect since both the sides are equal, but it's easier to use the equation if the side for which you are solving is on the left and values are substituted on the right. So now here's an example of an equation. We have x plus 8 equals 64, and we're asked to solve that equation. So when solving equations, the goal is to isolate the variable on one side of the equation to get it completely by itself in order to determine its value, or the value that makes the equation true. Remember, a solution is a value to an equation that makes it true. So our goal to find that is, again, to isolate. Get x, get that variable by itself on one side of the equal sign. So here you can see x currently is not by itself on one side of the equal sign. So it's on the left side of the equal sign, but it's with this plus 8. It has an operation with 8. So that's not isolated. It's not completely by itself. So we need to fix that. That's our goal using our rules. And one of the ways we can do that is using that first rule of inverse operations. So think about, if we have the variable x, how can we get it by itself? What would be that inverse operation? And how would you decide that? So let's actually break down what that means using these examples instead. So for each equation, we want to write the inverse operation needed to solve for the variable. So again, solving for the variable, we're completely isolating it. We're getting it completely by itself. So the first thing is to make sure you know where is the variable in the equation. So for example, the equation for A is y plus 7 equals 64. So we have the variable y, and it's on the left side of the equation. In B, a minus 21 equals 10, we have the variable a on the left side of the equation. In C, 5s equals 45, we have the variable s on the left side of the equation. And in D, x divided by 12 equals 7, we have the variable x on the left side of the equation. So again, these are the variables. We need them to be completely by themselves if we're saying we're solving. And you should see currently they're not by themselves, right? In A, it's y plus 7. We need to undo that plus 7. It's a minus 21. We need to undo that minus or subtracting 21. It's 5 times s. Remember, if you don't have any symbols in between a number and a variable, that's multiplication. And then in D, it's x divided by 12. So think of what is the current operation happening, and then what would be that inverse operation? What's the opposite that you need to do to solve for the variable? Well, in A, again, if we're solving for y, and currently it's being added with 7, the inverse or opposite operation would be to subtract 7. In B, if we're solving for A, currently it's being subtracted with 21, so the inverse or opposite operation would be to add 21. In C, we have 5s equals 45, so 5 times s, that variable s we're trying to get by itself, so the opposite or inverse operation of multiplying by 5 is dividing by 5. And then in D, we have the variable x, so that it's currently being divided by 12, so the opposite or inverse would be to multiply by 12. So these inverse operations are key if we're trying to isolate the variable. It's that step 1 or the first rule when thinking of solving these one-step equations.